Hi, everyone. Can you hear me okay? I think I'll stand over here and not behind the podium, because otherwise you might not be able to see me. Let's see, I'm Billy. I'm a Apache Hadoop committer, and I've been on the YARN team for the past few years. Before that, I worked on multiple different Apache projects, including Apache Accumulo. So this is an overview of my talk. I'm going to talk about the emergence of containers and why they're so popular. I'll talk about Hortonworks' journey to using a container cloud for all of our release testing, and talk about the features and changes we helped introduce into Apache Hadoop to make that container cloud possible. I'll go over the YARN service framework, APIs, and a few examples, because you can try out this containerization today in Apache Hadoop 3. And I'll also go into how this containerization work sort of helps lay the foundation for enabling hybrid deployments in on-premises and cloud clusters. I guess before I get started, how many people are using YARN today? Cool. Almost everyone. I guess this is a YARN talk, so that makes sense. Is anyone already using containers? A few people. Are you using containers on YARN or containers elsewhere? Are you using containers elsewhere? Yeah. Okay. And is anyone using Kubernetes? A couple of people. OK, thanks. So first, containers have become popular, and they're just getting more popular. The number of containerized applications is expected to continue to rise, and we're seeing multi-cloud and hybrid strategies where people are using containerizations in many different types of environments. People are adopting microservices, and overall we're seeing exponential ecosystem growth in containerization. There are dozens of different containers orchestrators and thousands of plugins. And we're also seeing financial investments in the containerization market. So why are containers so popular? Well, there are a lot of things that containers give you and why people are embracing containerization. So one is getting improved hardware utilization through increased density. So you don't have that virtual machine operating system overhead. In our example, on our hardware, we were able to get about 1.5 times the number of containers as we were able to run VMs on the same hardware. Let's see. Sorry, actually, I misspoke. I think it was 2.5 times. And even also with the storage, moving to containers, containers are composed of, the container images are composed of layers, and layers can be shared across different container images. So you don't have a lot of duplication on disk of, if you have like virtual machines that are just slightly different, you can't really take advantage of that fact, whereas with containers you can. So, and you can also get strong resource isolation with containers through namespaces and C groups. But personally, one of my favorites is that it has much better software packaging. So you can package your applications and their dependencies together in the container image. And that's a lot easier than just trying to tar up your application and its dependencies and pushing it out into all the machines, or possibly having your admins install different versions of libraries. So it's a lot more flexible with containers. It's a lot easier to run different versions of things on the same hardware. And it's easier to reuse those Docker images, primarily because there's like a built-in distribution mechanism through Docker Hub or private Docker registries. And that allows you to publish the images and reuse them, or other people can use them. And that also contributes to the improved developer self-service. So developers can, on their laptop or in a development environment, they can set up their image and have it configured exactly the way they want it to run in a production environment. So that sort of brings us to promise of portability. So the idea is this container image that the developer makes should be able to run in the same way on multiple different production environments, on premises or across multiple cloud environments. So as people are embracing containers, we're starting to see some architecture patterns develop. We're seeing people running long-running services and ephemeral batch jobs on the same systems. We're seeing a decoupling of compute and storage with containers. So the containers aren't storing their data locally. They're using some sort of external storage, such as cloud storage. And we're seeing hybrid deployments and really a desire for there to be common deployment mechanisms between the on-premises and cloud clusters. So, but the problem there is that on-premises and cloud clusters have pretty different models. With the on-premises clusters, you typically have a large multi-tenant clusters. There are a lot of different users using it. And you have co-located compute and storage and shared security and governance across that entire large cluster. And you have less agility due to running on physical hardware. And so like your analytic experiences like EDW or stream processing, data science, those are typically going to run on a fixed set of nodes, and it's kind of hard to change which set of nodes they're running on. I mean, it's possible, but it's not trivially done. Whereas on the cloud, you have not only like one large cluster, you might have multiple different clusters, and your compute and storage is decoupled, and that gives you a lot of flexibility. The infrastructure as a service allows you to spin up and spin down clouds and resize them easily. But on the other hand, there you typically don't have shared security and governance across all of your cloud clusters. When you're talking about a Hadoop cluster, they'll sort of have each individual security and governance. So in thinking about what's needed to bridge the gap between these models, so across clusters, we're going to want consistent deployment mechanisms for those analytic experiences and consistent security and governance across all of those clusters. And within the clusters, particularly in the on-premises cluster, we kind of want to make it look more like the cloud cluster in that we want it to have the decoupled compute and storage, and we want to eliminate that physical hardware barrier. And as you might guess, as this talk is about YARN and containerization, I'm going to discuss how YARN and containerization can help you do that. So moving on to Hortonworks' journey to a container cloud for our release testing. So when Hortonworks started out at the beginning, we had some on-premises hardware, but we quickly exceeded its capacity and we moved to the public cloud. That was working well, but the costs were higher than we wanted, and even more concerning than that, the costs were growing at a fast rate, and we knew we wouldn't be able to keep up. So we moved back to an on-premises model, and we were using VMs. So we started out with Cloud Stack and then moved to OpenStack. But we weren't capable of running that many tests on this infrastructure. The challenges there were we had low density. I think it was maybe 15 virtual machines per server. And there was a lot of overhead per test. Like it took a lot of time to spin up those virtual machines for each test. And we were using a lot of disk storage to store all the virtual machine images, which weren't really that different from each other, but it was taking a lot of space. And more and more, well, I guess the ecosystem keeps growing, so we keep getting more and more products. We want to test more and more things. And more and more different teams wanted to use it. So it couldn't really keep up anymore, so we wanted to find a new solution. And this was about 4 years ago. We were looking for the new solution. So we were looking at how the industry was addressing the challenges, observing the rise of containerization, and we wanted to be able to leverage our existing hardware while doing all of those things that containerization helps with, reducing our overhead, improving the density and hardware utilization, and also taking advantage of the packaging and automation improvements. So the solution we came up with at that time, about 4 years ago, was to use containers to eliminate the VM overhead, get the better image reuse, and the faster startup time of containers. And we decided to use Apache Hadoop YARN, both because it was a good technical fit and it was a good strategic fit. And I'll go into both of those reasons in more detail. So first, why YARN? YARN is Apache Hadoop's resource management framework, and YARN has always had a container model. And when I say that, I don't mean Linux containers, which is how we talk about containers today, but YARN's fundamental idea is orchestrating containers across a set of servers. And from YARN's perspective, a container is just a Linux process, a set of resources, which are files such as scripts or jars or security tokens, and a set of resource constraints that a container isn't allowed to exceed. So this model aligns well with the Docker container model. So when we move to YARN running Docker containers, the Linux process is just going to be the Docker container process. And then the local resources are going to be the Docker image. And you might also have some additional files that you want mounted into the Docker image. And then the resource constraints are just going to be work the same way as with Linux processes, because we can use C groups to do that. So beyond the technical reasons YARN was a good fit for running our container cloud, it was also a good strategic fit because YARN is already widely deployed. A lot of people are using it. It has a superior scheduler, and it still does. It's been hardened by customer feedback. And it allows us to leverage our existing expertise. We already know YARN well, and actually using what we ship allows us to improve the software in a way that we wouldn't be able to otherwise. And furthermore, for both us and others, introducing the containerization capabilities into YARN allows people to try out containerization while they're still running their existing Hadoop workloads. So you don't have to redo your entire infrastructure to try out containerization. It can coexist with what you already have. So this is the rough architecture diagram of what we came up with for our container cloud. We have Jenkins running in Docker containers. They submit tests to our Apache Hadoop YARN cluster, which is going to launch a set of Docker containers running on YARN. And we install HDP or HDF or whatever software we're testing in that container cluster that's running on YARN. So we have HDP running on HDP, effectively. And this has been very successful. We've been running it in production for over 3 years. We've run over 9 million containers now. And we've certified multiple Hadoop release or HDP releases entirely on this infrastructure. So we don't have a separate backup infrastructure that's doing testing. All of our testing is done here. And it's grown over time. I think we're up to over 300 nodes now, and still increasing. And we're not testing CDH on this yet, but we hope to also do some CDH testing and future product testing. So how did we make this container cloud happen? So there are 3 main elements that have been introduced into Hadoop to make this work. One is the Docker container support in YARN through container runtimes, the YARN services framework, which is a YARN application master implementation that basically you just give it a JSON specification and then it spins up containers for you based on what you requested. And the service framework also has easy ways of interacting with it. And lastly, a service discovery mechanism. And I'll go into each of these in more detail. First, the container runtimes. Already at the time we were looking into this, there was a Docker container executor for Yarn. The executor is what the node manager uses to launch the container processes. So the problem with the Docker container executor was that you had to switch your entire Hadoop cluster over to only running Docker containers. So with the newer runtime support, basically runtimes are plugins for the Linux container executor. So on a container by container basis, you can decide whether you're running a plain Linux process or a Docker container. And this allowed us the flexibility to do what we really wanted to do with the containerization. And it's really easy to configure your application to tell the Linux executor what types of containers you want to run. You just set a couple of environment variables, setting the runtime type to Docker and the runtime Docker image to the name of the image you want to run. And these are examples for the distributed shell application and the MapReduce application. And you can see you can configure possibly different runtimes or different images for the maps and the reduces of your MapReduce. So the runtime support was kind of the initial level Docker support, and that's been around for a few release versions. I can't remember 2.8 or 2.9. But we've continued to improve the Docker support. Some more recent efforts have improved the container security. We have ACLs for privileged containers now. We have better out-of-the-box security, so if it's an untrusted image, you won't be able to mount files into it. And we also added support for entry point. Originally, we were always overriding the command that you're running in the Docker container, but now we let that be specified by the image, which gives applications a lot more flexibility in how they're running. And another exciting thing that happened very recently was the ability to remotely exec into a container, which there's actually a link in the Yarn UI. You can click on the container, and it pops up a remote shell into the container, which I think will be very useful for debugging to find out what's going on in the container. Let's see. And besides that, there are some efforts that are still in progress. We're working on improving image management and how images are pushed and pulled to all the nodes. And we're also looking into, generally the community is looking into support for other container runtimes, such as the runc and squashfs support. And let's see, another big effort that's partially completed, still in progress, is the support for CSI, the container storage interface, which is the storage plugin that allows you to store data from containers to places such as S3 or Ozone. And that's the same interface that Kubernetes uses. Okay, moving on to talk about the Yarn services framework. So the goal for the services framework was to support long-running services, for one. Yarn was originally designed around batch jobs such as MapReduce, so the containers run for a while and then stop. We also wanted to be able to support containers that just keep running until you tell them to stop. And we also wanted to make it easy to bring new applications to Yarn. So instead of having to write any code, previously you had to write your own application master in Java. So now you can just provide a JSON specification, and the service application master will take care of requesting and launching containers for you. And lastly, we wanted both a REST API and a nice CLI interface for launching and managing your applications. So here's an example of a simple JSON specification that you can use to launch an application. This is probably the simplest specification you can have. So there's one component here, and it's requesting 2 containers, and the launch command is just going to sleep. And this isn't going to be run in a Docker container. It's just launching a normal Linux process. And so the service framework is going to name those containers. They'll be called Sleeper 0 and Sleeper 1, which is based on the component name. And even though this is like the basic specification, there are a lot of other things you can add into it to customize it. So you can add readiness checks, placement policies for your containers, and you can have the AM create config files and mount them into your container if you need to. Let's see, so basically you just take this JSON specification and either pass it to the yarn app launch command line, or you can post it to the REST API endpoint that's running in the resource manager. So the last element that has been added into Yarn to support the container cloud is a service discovery mechanism. There was already a Yarn service registry that was backed by Zookeeper, and that was used primarily by Apache Slider, the incubator project that was sort of a precursor to the Yarn service framework. But it was a little inconvenient to have like custom mechanisms of interacting with the registry, so we really wanted something DNS-based because everything understands DNS. So now there's a Yarn registry DNS daemon that watches the Zookeeper registry, looks up the service records that are written there by the Yarn service AM, and then hosts DNS records for those containers. And this DNS server works well with other DNS servers, so your corporate DNS server can effectively delegate a particular domain to this DNS server. And the way the domain works is you just configure a domain in the Yarn site file, and that will be the domain for all of the containers running on your Yarn cluster. I have a couple of examples of the user-friendly DNS records that would be created by registry DNS. One is based on the component instance name, so the Sleeper 0 or Sleeper 1 in my previous example, the service name, user, and domain. So that would be sleeper0.sleeperservice.billy.domain. And there's also a container ID-based host name that's useful in some cases. But the cool thing about the component instance name one is you know that before you've started the application, if you know what service name you're going to use. So users can take this user-friendly name, you can give them that endpoint, and then they can visit it. Actually, another cool thing about it is you can also use those to configure your application. So if we're configuring HBASE, which I have a partial example of later, you can configure the HBASE master host name using this user-friendly name. A brief overview of the Yarn service APIs. So you create a service by posting the JSON to the services endpoint in the resource manager. You can also get back the service status by doing a GET request to the service name endpoint. You can also update the service. So you can extend its lifetime, stop it, start it again, flex up or down the number of containers it's running, and you can delete or destroy the service. Similarly, you can perform all of those operations through the command line. You can use the yarn app launch command, use the yarn app flex to flex up and down the number of containers. You can save a JSON without actually starting the application and then start it later. You can stop a running application without destroying everything, or you can destroy it. And you can also get the application status through the CLI. Going into a few more examples that you can use today with Hadoop 3. This was our original basic sleeper example. So if we want to take this and turn it into a Docker example, all we have to do is add an artifact to the JSON spec. The artifact type will be Docker, and the artifact ID will be the name of the Docker image. So now your launch command of sleep is going to be running in Docker containers on Yarn. Going into a bit more complicated and useful example, this is an HBASE TARBALL example. So the artifact is the type is going to be tarball, and the artifact ID is going to be the path to the HBASE tarball in HDFS. HBASE needs a lot more configuration, so you can specify environment variables, and you can also specify config files that the service AM is going to localize for your container. So in this case, our config files are some Hadoop configuration files and also the HBASE site file. And actually at the bottom there, you can see for the HBASE master host name, I'm setting that user-friendly DNS host name via some variables that will be substituted by the service AM. So this configuration flexibility is really useful. So you could just change your Docker image to have the appropriate HBASE site. But if you're just making little changes to HBASE site, maybe you don't want to have an entirely different image. So it's nice to be able to inject just some slight configuration changes at runtime. So to convert that HBASE tarball example into an HBASE Docker example, you really just have to make a few minor changes. The artifact you'll convert from a tarball artifact to a Docker artifact. For a Docker application, you'll probably have some of the environment variables already pre-configured in the image, so you won't need to specify as many of the environment variables at runtime. On the other hand, you might want to mount some of the host environment into the container environment if that HBASE container application is reaching out to, say, an HDFS outside the container. Let's see, as far as the config files, so with the tarball app, basically Yarn is constructing your container working directory, and the tarball and the config files and everything will be in that container working directory. Whereas with the Docker application, it can use the, say, etc HBASE conf, etc Hadoop conf directories, since it's isolated from the main host. So the locations of those files can be changed to absolute paths, effectively. And you might not have to specify all the config files because they could already exist in the image. Stuff you're not really changing, like the log4j properties, they can just already exist in the image, and you don't have to change those. And lastly, you would probably just adjust the launch command to specify the location of HBASE in the image, or you may even be able to use the entry point. So, there are a few things, but they're really not that complicated to go from a tarball normal Linux process application to a Docker application. Okay, so I've gone through the Yarn containerization, and now I'm going to try to put that in context of our sort of overall roadmap and what people might want to do with hybrid deployments. So here's an example of what an infrastructure might look like. You may have multiple different cloud clusters with different cloud providers, and you may have a larger on-premises cluster. And these might have different types of data. So you might have more sensor data in the cloud clusters and more operational backend data, maybe like customer billing data in the on-premises cluster. And if you recall, we have this problem where we have the really different models between on-premises and cloud. So the thing we can sort of provide the foundation for with the Yarn container cloud concept is we can bring these models closer together. So in the on-premises, we can decouple the compute and storage by using the Apache Hadoop YARN containers and storage such as Apache Hadoop Ozone. And then we'll be able to have similar security and governance layers and similar deployment methods for things like EDW and stream processing on the on-premises cluster and the cloud cluster. And if we sort of zoom out a little bit, so basically at the top level, we'll be able to have a unified control plane, the Altus data plane layer, which will be able to deploy your analytic experiences. And the containerization will allow those deployments to be basically the same or similar on your private cloud clusters and your public cloud clusters. And they'll also enable our security and governance layer to work similarly across these clusters. So, in summary, I've told you about Apache Hadoop YARN containerization and how that helped us with our container cloud. And you can try that out today with Apache Hadoop 3.1 and later. The containerization capabilities are working. We've been using it in production. So I recommend giving that a try. And we also hope this will help us on our path to our unified hybrid cloud infrastructure. Thank you. And any questions?
Can you bring back the slide with Jenkins?
Yeah, let's see.
You know why?
Yeah. Let's see. Just a couple more. Okay, there we go. Yeah. Yeah. So the Jenkins ones are those running? I can't. Those might be running on Yarn as well, but just a separate process. I mean, we also have like.
I mean, just as a part of the CI/CD, because for me now it's challenge is really to deploy deployment with that different fine differences between various deployment, but as quicker it goes, the better. And for me, release is not the HDP release spec. That's just my configuration for a particular purpose, and that's this for me the idea of Yarn combining Yarn and Docker. Originally, it sounds to me a bit that they're overlapping in functionality.
Mm.
And now you see we can really come together, but for me, it's still not clear if I would do that on premise. Yeah, so
Can you use the microphone? Yeah.
Does it work? Oh,
Yeah.
okay. So the question of inside CI/CD or let's say automation take place, or it's substituted by Docker and Yarn, let's say functionality.
Let's see. No, I wouldn't say it's inside. It's just a tool that's used by the CI/CD. So, I mean, we need a bunch of Jenkins workers, so we're spinning those up on Yarn. But then I wouldn't say the other clusters are inside the Jenkins cluster. They're just sort of reaching out to the overall cluster. They're calling the REST API to launch clusters.
Okay.
I've got a follow-on question that might
Yeah.
make it.
Great.
Just a follow-on question that might make this more apparent. If I were running my Jenkins workers in Yarn as a Yarn service container, do I get a delegation token that would allow me to then talk to Yarn or HDFS to then submit another job for testing, for example?
Yeah. Let's see. So this particular cluster is not secure. Our next generation cluster that we're working on, what it's, yeah. So our next generation cluster is secure, and we do test the secure version of HTTP 3.1. So yes, the delegation tokens should work, and the way we test it, specifically the HBASE test, the HBASE running in containers is using the HDFS of the underlying cluster. So that has to do the reaching out outside the container. And there are some challenges there, but it does work.
So it would be, just to understand that it would be the normal process. Like today when I spin a Yarn container up, I'm running, in a C group, but my local directory has the Hadoop delegation token file. That would be inserted into my Docker process then at that point? And
Yeah, so kind of with the launch command method of running, besides basically the container working directory is mounted into the Docker container, so it can use the things that are there. Let's see, I think it is the working directory for the command that's run in the container. So I guess that's part of the reason we were originally overriding that command. So all of that
kind of works by default then.
Yeah. So I mean, the drawback there is it's kind of hard to use off-the-shelf Docker images. You have to make a few modifications to make them work well on Yarn.
Very cool though.
Yeah.
Thank you.
Any other questions?
So my question is about which component like manage or orchestrate Docker containers, and like in future we will be able, is it possible to get auto scaling features inside Yarn containers?
Let's see. Yeah. So doing the second question first, we have sort of started to think about auto scaling and how that would work. I don't think we even have a ticket open about it yet. But let's see. I'm not sure whether we'll end up implementing that in the community or not, but that is sort of something on our radar to think about possibly implementing. And you asked which component is doing the orchestration. What do you mean?
Like for instance, if a Docker container fails, and is there any mechanism to restart it?
Yeah, let's see. So the Yarn framework handles that. So the node manager is what's launching the Docker containers. And actually now the the node manager has an automatic restart for containers that you can configure. So instead of allocating a new container, it'll try rerunning the existing container first, depending on the failure mode. But even if it doesn't work to restart the container on the same node, if that container goes down, the resource manager and the application manager will notice that, and the application manager will request another container. So it will spin up a new one, basically, if one goes down.
Could you give us more insight on the network
incentive? And for example, are you using are you dedicating private IP per container? Are you planning to integrate CNI?
Let's see. Yeah, there's a ticket open about CNI. I don't think it's currently being worked on, but that's also something that's being thought about. Currently for our prod cluster, basically we use a fixed CIDR, so each host has a non-overlapping range of IPs for Docker containers, and they're like publicly addressable within our VPN. So we don't have, let's see, a set of containers for an individual application doesn't have its own networking where they're talking to each other, but anyone on our VPN can access any of the containers from wherever they are. From our laptop, we can get to the containers, or the containers can all address each other based on those host names and DNS or the IP address. So it's, I would say the fixed IP mechanism is like a little bit harder to set up, but it's so much easier to use that it's been very useful.
I've a perhaps obscure question, just because I was kind of a motivation behind Yarn being able to do the network classes for legacy Yarn containers. Do you know if the network classifier code from the Linux container executor would still get run, where at least each Docker container would be put into its own network class by user?
Let's see.
Sorry, it's rather obscure, so I
yeah,
fully understand
I'm
it,
not
but
sure.
I've never
Sorry,
tested that.
network class.
It was like Yarn 7468, but it was basically, but for those who couldn't deploy CNI, you know, didn't have BGP routing or whatnot, it just puts each legacy Yarn container into a network class based on a mapping file, and so then you can have static rules and then IP tables set up on each of your node managers to control policy for that network class.
Yeah, I guess I'm not sure of that specific issue.
That's it.
Sorry.
Yeah. Thank you.
Sure.
Do you see one day Yarn being replaced by Kubernetes, and if not, why not?
Let's see. It's hard to tell at this point. Kubernetes is still pretty young, and some of its capabilities are not up to what Yarn can do as far as the container throughput and the scale. But it is a very popular containerization framework, so if it improves at the current rate, possibly it will be able to do the things that Yarn can do now. But Yarn is not yet a popular containerization framework, so I suggest trying it out and see what works for you.
Okay, thanks. Well, last question. Well,
Yeah.
on Kubernetes, you have this implementation of the storage claim and the storage class implementation. So here it's a bit different because HDFS is by default outside of the container. So do you think in the future having some kind of abstraction of the HDFS layer?
Let's see. I think we'll probably move towards using Ozone,
Okay.
which we already have the storage interface capability for, so the containers can write to that. I don't know if it will make sense to do something like that for HDFS.
Well, the point will be to abstract the way you store your things. It will be on cloud, on-prem, whatever you can choose, the kind of storage that will implement then is GFS.
Yeah, it could be.
Yeah. Okay, thanks.
Thanks. Any other questions? Yeah, well, thanks for coming to my talk.